Hey everybody, this is your last lesson of Chapter 8. It's called Factoring Completely. It's for 8-7. This is the lesson where you get a problem and you have to figure out what to do. So all the other lessons so far, I've told you the equation to use or the way to solve it, and now they're all going to be thrown at you and you have to decide how to factor it. So to give you some help, there is a chart here, and I'll have it on each of the slides as we go through problems. But these are what you have done so far. So you have the number of terms. It'll tell you how many terms. It'll tell you what it was called, so you could look like at the top of your note sheet or in your textbook, and it'll give you an example of the problem. So we're going to get a problem, and we have to figure out how do we solve this thing. And so you could take the difference of two squares. It can be a perfect square trinomial where a was 1. It can be the product of two binomials, and it can be factoring by grouping. And going back to that perfect square trinomial, a doesn't have to be 1 either. So we know how to solve it that way as well. All right, so here we go. Let's try 4 problems today. All right, so at the top, I'm going to give you that box so we can figure out which one it is so we know what to do. But there's actually going to be one step before now that we've never done. We've kind of done it. We haven't really done it, though. And step 1 is going to be, do my 3 terms have a common factor that I need to pull out? And if the answer is yes, then I need to pull it out. So if you know something about 64, 96, and 36, the first thing you should see is, wow, those numbers probably have a factor in common. Well, they do, and it's a 4. So I'm going to move my up just a little bit so I can write. But I have a 4 that I can pull out of each of these. Now let's consider the variables. There's x's in the first 2 terms and y's only in the second 2 terms. We cannot pull any variables out because they're not shared amongst all 3 terms, but I can pull out a 4. And then I can rewrite this problem. Well, 64 divided by 4 is 16. Leave my variable. 96 divided by 4 is 24. Leave my variable. And 36 divided by 4 is 9. Leave my variable. All right, now that I have this right here, I need to go up and figure out which one is it. Okay? Well, I've got 3 terms. And since I have 3 terms, I might want to look at these 2 because they have 3 terms. So the first one's called a perfect square trinomial, which means there has to be a perfect square here and a perfect square here. And you know what? 16 and 9, y squared and x squared, hey, they're all perfect squares. So the one I'm going to use, and maybe what we'll do is we will circle it so we know which one we're using for this problem, is the perfect square trinomial. Okay? If we want to check that, let me remind you how to do that. So the check for that is to unsquare the first and last term. So this would be 4x, and this would be 3y if we unsquare it. The middle term had to be 2 times 4x times 3y. It has to be 2 times those outside terms. So let's double check that it is. Well, 2 times 4 is 8 times 3 is 24. And x times y is xy. We have this problem. Okay? So let's go back and see how we're supposed to write our answer. So if we look at this 3-term perfect square trinomial, I look and it was plus, 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 plus. So I'm going to use this top one right here. It is just the number unsquared plus the other number unsquared and then putting the squared symbol on it. So we go back down. I'm going to change my pen color here. We would use this 4x. Since it was plus, plus, we would write addition. And we would have our 3y squared. Now here's the only thing, the one difference, let's make that a better plus sign, is I had this 4 on the outside here, which does mean I need to include it in my final answer. If I hadn't done this 4 on the outside, it would not have been factored completely. there still would have been things inside that I would have had to pull out. So our new step is first look at all the terms, see if you can pull anything out, then factor. All right, so that is factored completely, number 1. Number 2, I have 3a squared minus 9a minus 12. I got 3 terms again, but I first want to see if I can pull anything out. 3, 9, and 12 do have a factor of 3 that I can pull out. So I am going to pull a 3 out of all this. I'd have a squared minus 3a minus 4. All right, so I'm going to go up and look at either this one or this one because I have 3 terms, okay? The first thing I want to consider is perfect square. Now, a squared and 4 are perfect squares. That potentially could work out. But it also sure looks like this one too. And so I'm going to give you a little hint that we are going to use this product of 2 binomials right now. Because if you try it with a perfect square, it's actually not going to work. And so we're going to use this product of 2 binomials. So when I have, there's no number in front of the a, yay! I need to just figure out what 2 numbers. So my AC, my 1 times -4 is -4. All right, so I need to find all the factors for -4. 1 and 4, 2 and 2, and I need to make -3. So that negative's got to go right there. So if you remember, this is 8, 2. We can just use those 2 numbers. We don't need to rewrite the middle term and factor by grouping because there's no number in front of the a squared. So we can just have our final answer of a plus 1 and a minus 4, which I just took from right here. So I wanted to make -3. And that's why it's not a perfect square trinomial, because that didn't come out to the same thing. And then I don't want to forget, I need to add this 3 on the outside. It is now factored completely. I know this is tricky, so if you need to go back and watch my problems, do that. All right, number 3. Oh, there's only 2 terms. Well, I only have 1 2-term type thing up here, so hopefully it fits. All right, so first things though, I want to check if I can pull anything out. Well, 4 and 36 do share a factor of 4. So I'd have n squared minus 9. All right, let's see if it works with this difference of 2 squares. So it has to be a perfect square, and it is. And it has to be a perfect square, and it is. And it has to be a subtraction sign, and it is. Which means we can use our rule here to make this a perfect square. So let's look at how they wrote their answer. They unsquared 16x, and they unsquared 25, and then 1 is plus and 1 is subtraction. So that's all we have to do. We have to unsquare n squared and unsquare our 9. And if we unsquare them, it's n and 3. And then we just need 1 to be addition and 1 to be subtraction. So my final answer would be n plus 3 and n minus 3. And not forgetting that I have to throw a 4 on the outside of it because I pulled it out to begin with. That is now factored completely. And actually, I wasn't consistent. I should circle this here in case you want to write it down. That is the one we used. All right, one more. One more. All right, so we are going to see if there is anything we have to pull out. So let's consider the numbers first. 13, 65, and 26. And you might have to consider it for a minute, but I'll tell you that they share a factor of 13, actually. Now let's look at the variables. M, no m. So I can't take any m's, but n squared, n squared, n squared. I can pull out an n squared out of this whole thing. So if I divide each of these terms by 13n squared, I'm going to get 3n squared. And 13 divided by 65 is 5m. And 26n squared divided by 13n squared is 2. All right. So I either have this one or this one because I have 3 terms inside there. And so I'm going to use, if they're not perfect squares, so I'm going to have to use the product of 2 binomials. All right, so let's review how to do this. This is lesson 8.3 if you need to go back with how to do this. But we need to figure out what AC is and add to B, okay? So AC is 6. And my factors are 1 and 6 and 2 and 3. Now I want this to be a positive 6 and I need this to be positive 5m, which means I am going to choose 2 and 3. I know I could make this like negative 6 or negative 1, but I don't want that because this has to say positive 6 when I multiply. All right, we're going to drop off the 13n squared for just a moment, and then we're going to rewrite this. So hopefully this rings a bell. I need to rewrite the middle terms. So let's put the 3, oops, we got the plus. Put the 3m plus 2m. I am replacing that middle term with that, and then plus 2. Now I have to factor by grouping, actually, because I've got 4 terms, so I'm kind of using 2 of them here, and I need to pull out the greatest common monomial factor. So this is kind of like we're factoring by grouping. So I know that we used the product of 2 binomials, so that's what we're using, but actually we kind of have to use both. All right, so 3m squared and 3m, pull out a 3m. That would leave me m plus 1. 2m plus 2, pull out a 2. That would leave me m plus 1. Perfect, that's what I needed. My 2 binomials are 3m plus 2 and m plus 1, but I don't want to forget I pulled out a whole 13n squared out of this thing to begin with, so I add that on there, and that is now factored completely. All right, so good luck with your homework. Rewatch this as you need to. Try some factoring completely. Good luck, everybody. Miss you all.